So we just got done talking about all kinds of common functions that we see and looking at how to graph those things and being able to answer questions when we look at the graphs, domain and range, increasing, decreasing, constant, all of that kind of thing. Now we get into all the transformations, which you guys did in Algebra 2. We will use more functions than you did then, but all of the same basic rules apply. Now, stretching and shrinking, did you guys do very much of that last year? A little bit, maybe? So vertical stretching and shrinking. Basically, what you have to remember with transformations is anything on the outside of your function changes y and it does what it says. So if I have 2 times x squared, I'm multiplying by 2. It's like saying you take your y values times 2. It's like taking a rubber band and stretching it. It's going to get tall and skinny. Okay, if I say 1/3 times x squared, it's like taking my height times 1/3. So it's going to get short and fat. We'll squish it down. Now, inside is affecting x, and it does the opposite of what it says. So something on the inside would be like if I said a 2x and then the square is out here. Okay, vertical, you would have the 2 in front just times your x squared. But do you guys see the difference when I say inside versus outside? This 2 is inside my square. And so that's changing x. And it does the opposite of what we're saying. So it's not saying it's going to take all of my x's times 2. It actually will take our x's and divide them by 2. So it's going to squish my graph in. Okay, so it's like a horizontal shrink. If I put a 1/3 in here, okay, so if you do the opposite, that's like saying you divide your x's by 1/3, which is dividing by 1/3 is the same as multiplying by 3, so it's going to stretch it out and make it get really wide. Now the horizontal stretching and shrinking, it's just hard sometimes. If you are struggling, you can always go back to making a t-chart, or you can graph it and then compare it with the graph on your graphing calculator and make sure it looks reasonable. Keep in mind, when I ask you to do these, I will require a couple things. I'm going to require the parent function, and we'll always draw that with a dashed line. And I will require the final function, and both of those will have to have a minimum of 3 exact points. So I don't want you just looking at your graphing calculator and say, oh, yep, that looks like a skinny parabola, and drawing me a little skinny parabola and hoping for the best. I'm wanting exact points on that, and I will be checking that you have those exact points. So let's take a look at a couple. All right, so first thing I would want is a parent function. What is my parent function? And the parent function is just the x cubed. Your parent function is one of those basic functions that we've been working with. So we've had like x squared, a square root, x cubed, a cube root, absolute value, all of those different things. So if I want to graph x cubed, and I know I have to have at least 3 points, 0 cubed is 0. 1 cubed is 1. -1 cubed is -1. Is that enough to get my graph? If you know what x cubed looks like, it's 3 points, so that's enough. If you don't remember, you could always do more. What would be another point? 2, 8, -2, -8. Remember, this is just the chair. So that's the first thing. You get a point for drawing that parent function. And we always want that to be dashed. If you don't make it dashed, you have to label on there which one it is. Then I want my final function. So this is 2 times x cubed. So the 2 is on the outside. So that is changing y, and it does what it says. So it's saying like a vertical stretch. Or if you think about it another way, it's saying you take your y's times 2. Sometimes people really struggle with that. So one thing that I sometimes do with people is write out these ordered pairs on your parent function. Okay, you don't have to do this, but if you don't know how to stretch it by 2, then we can use these points to help us. I told you outside changes y and it does what it says. So what should I do to my y's? Multiply by 2. So here are my y's. I'm taking those times 2. So 0 times 2 is still 0. 1 times 2 is 2. Negative 1 times 2 is negative 2. My x's don't change, it's just changing my y there. So then we just plot those points. So we have 0, 0, 1, 2, negative 1, negative 2. And we see we just get a skinnier version of the graph we had. If you had more points, you know, if you had put the 0.28 on your parent function, what would it become? You just take your y times 2. If you had 2, negative 8, it would become negative 2, negative 8 would go to negative 2, negative 16. So you can put as many points as you want. 3 is just our minimum. Questions there? You guys try B. So same parent function as last time. So we had 0, 0, 1, 1, negative 1, negative 1. If you wanted more points, you could do 2, 8, and negative 2, negative 8. And that's up to you. What's happening this time? What's my transformation? Still on the outside, so it's still changing y. But since I multiply by something smaller than 1, it will shrink my graph. So if you think about your points, you're taking those y's times a half. So 0, 0 won't change. 1, 1 will go to 1, 1 half. Negative 1, negative 1 half. If you wanted to do more points, you know, we had 2, 8. What would that point be now? Or you could do negative 2, negative 4. So what we see is just same shape, just got a little shorter and fatter. Are those okay?
Yep.
All right. How many of you are writing out those ordered pairs? Does that help?
Yeah.
Okay. All right. I'll keep doing it then. All right. So this time, I'm going to have us do a couple graphs all on the same thing. My parent function is the square root of x. So what would I put on a square root of x? What points do I plug in? Square roots. So let's start with 0. Square root of 0 is 0. Square root of 1 is 1. What else? 4, 2. If you wanted, you could go up to 9, 3. You have to have a minimum of 3. That's my parent function. All right, so the first thing I want you to graph is the square root of 3x. Okay, this is sometimes harder for people. In a pinch, if you couldn't get it, you could always go and make a t-chart for the square root of 3x. Okay, worst case scenario, we can still get an answer. But let's try to do our transformation. I told you inside changes x, and it does the opposite of what it says. So this is actually going to be, you're looking at your list, this is a horizontal shrink when you have something bigger than 1 in there. So it's going to change x, does the opposite. So it says times 3, so the opposite of multiplying by 3 would be dividing by 3. So my y's won't change. So 0 divided by 3 is 0. 1 divided by 3 is 1/3. 4 divided by 3 is 4/3. 9 divided by 3 is 3. So these will be the points I plot. 0, 0, 1/3, 1, 4/3, that's like 1 and 1/3, 2, 3, 9, so a horizontal shrink looks a lot like a vertical stretch. When you take it and you squish it in, it's forcing it to get taller. And that's what happened. We kind of compressed it this way, so it got taller. That one okay? So the next one, f of 1/3 x. So that means the square root of 1/3 x. That's my horizontal stretch. Okay, if you think about our points, we're still changing x. The y stays the same. What am I going to do to my x's this time? Opposite of multiplying by 1/3 is dividing by 1/3 or multiplying by 3. So 0 times 3 is still 0. 1 times 3 is 3. 4 times 3 is 12. 9 times 3 is 27. So these are the points on my graph. 0, 0, 3, 1, 12, 2. I don't think I'm going to graph 27, 3. I've got my 3 points. So that horizontal stretch, stretch it out so it gets shorter and longer. All right, stretching and shrinking is usually the most difficult transformation for people. Are we okay? Are we doing okay with these? I really recommend writing out those ordered pairs if you struggle. That's the visual for me. It kind of shows exactly what's changing and how it changes and helps make sure you get the right points on your graph. All right, let's see if we can do a few more of these. I'll do a couple, then you can do a couple. 1/3 x squared. What's my parent function? X squared. So 0 squared is 0. 1 squared is 1. Negative 1 squared is 1. That's all you have to have. If you wanted to do more, you could do 2, 4. Negative 2, 4. And then what am I going to do? Horizontal or vertical? It's just this being squared. So outside is vertical. Less than 1 would shrink. If you're thinking about your ordered pairs, what changes, X or Y? Y. So we're going to be taking our Y values. Outside is Y, and it does what it says, so we're just going to take those Y's times a third. So 0, 0 stays. Then we'll have 1, 1/3, negative 1, 1/3. If you wanted to do more, this has a Y value of 4 times a third is 4/3. On B, same parent function. What's going to change, the X or the Y? Inside is X, and it does the opposite of what it says. So it says take X times 4. So what will we really do? Divide it by 4. So 0 divided by 4 is still 0. 1 divided by 4 is 1/4. Negative 1 divided by 4 is negative 1/4. So we have 0, 0, 1/4, 1, and negative 1/4, 1. That horizontal stretch looks a lot like a vertical shrink. I want to change D, I'm going to change that. Let's do a 3 absolute value of X. I want you guys to do C and D for me. So this first one, inside, does it change X or Y? X, and does the opposite of what it says. So it says take X times 0.25. So what do we do? Divide by 0.25 or multiply by 4. So did everybody have the right parent function? Looks like a V. So if you take those X's times 4, you get 0, 0. 1, 1, if you take your X times 4, we'll go to 4, 1. You could do 2, 2 if you wanted. It would go to 8, 2. Negative 1, 1, if you take your X times 4, goes to negative 4, 1. Negative 8, 2. So we get this horizontal stretch. Looks like that. Is everybody okay with that one? I see several people erasing. What did we miss?
Where'd you get 4? I didn't
Oh.
understand.
0.25 is the same as 1/4. So you can divide by 0.25, and that's the same as dividing by 1/4 or multiplying by 4. It's all equivalent. D. Is this one changing X or Y? Y. Outside is Y, it does what it says. So it says take your Y times 3. So we get 0, 0, 1, 3. If you did 2, 2, it would go to 2, 6. Negative 1, 3. Negative 2, 6. So we just get this tall, skinny absolute value. And hopefully maybe you guys hit your points and I'm missing them on mine, but we get the idea, right? Okay, how are we doing on this? Stretching and shrinking, that's the trickiest piece. Let's talk about a few more of the transformations before we stop for the day. So the next step, we have reflecting graphs. So that's like flipping. That's caused by a negative. Outside, it's y. So if you think about a graph, if you take the y's and make them negative, it flips it over the x-axis. Okay, if it's on the inside, it's making your x's negative. So if you take your x's and make them negative, it flips them over the y-axis. Adding and subtracting, outside is y and it does what it says. So if you add to your y, it moves it up. If you subtract from your y, it moves it down. Inside, when you add and subtract, it does the opposite. So when you add, it will move it in the negative direction. It'll move it to the left. When you subtract, it moves it in the positive direction. It moves it to the right. So, let's just practice these. Parent function and transformation, always. This is a little bit nicer because I put a grid on here for you. Maybe a color that'll show up on my grid. Good. All right, so x squared is my parent function. So 0 squared is 0. 1 squared is 1. 2 squared is 4. Negative 1, 1. Negative 2, 4. Does everyone know how I get these points on my parent function? So a negative out in front does what to my graph? It's not on the inside because it's not in my square, so a negative out in front. It's like making my y's negative, so I flip each point over my x. So if it's on the x, it stays. These points will all just get flipped down. So we end up with an upside down problem there. Is that example okay with everyone? B, what's my parent function? Square root. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. We could do 9, 3 if we wanted. So this is a negative inside. It's under my square root, so it's inside. So it flips it over the y-axis. So essentially all you're doing is taking each point and making the x negative. Now, I have tons and tons of practice on here. We may or may not do them all. We're just going to kind of see how you guys are doing as we go through. How much of this stuff do you guys remember so far? Am I boring you, or do we need to be going through this?
I think
It's needed? Okay. Do we need a couple more flipping ones? Yeah.
So why was A flipping over the x-axis and minus flipping over the y?
Okay. So outside, it's like taking your y value. So this one's outside the square. So if you think about like your points, outside changes y. So it would be taking these points and making the y's negative. And so when you do that, it puts them down here, so it flips it over the x-axis. And then this one was under the square root, so it's affecting my x's. Other questions? Let's go to this one for now. We might go back and do those other two. I might kind of start bouncing around a little bit. Unless you see an example that you really want to make sure we do because you don't know how to do it, definitely speak up. All right. What's my transformation on A here? Up 4. It's on the outside because it's not part of my cube. Outside is y and it does what it says. So plus 4 would move it up 4. So my parent function is x cubed. That's the chair. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. Negative 1, negative 1. Negative 2, negative 8. And so then, we just take each one of these points that we graphed and move them up 4. What's that one going to do? Down 2. It's not inside my absolute value, so it's changing x. You know, the absolute value is just a v. Minimum of 3 points on each.